Hey, what's happening guys? In this video, we're going to be using Babashka to make a password manager. So let's get started. So if you're not familiar with Babashka, basically what it does is it allows us to write scripts using Clojure. It starts up way faster than using the JVM. It doesn't run on the JVM. And it also comes with some helpful tools for creating command line applications. So to install it, we just go to book.babashka.org, go to getting started. We go to installation. I'm going to go to the GitHub repo here. And here, I think we can copy and paste the script. Yeah, we can copy and paste this and it'll install Babashka for us. So you run Babashka using BB. I don't have it installed yet, so I'm just going to copy this. I'll paste it. And now it's going to download it for us. Once it's installed, we should be able to evaluate Clojure forms at the command line using BB. So let's do this and let's just create a form here, +1, evaluate it, and we should get 2. Awesome, and that was super quick. So let's create a directory here. I'm going to call it passman for password manager. I'm going to cd into passman and I'm going to open it in VS Code. Now the first thing I want to do is create a bb.edn file. So if we go back to book.babashka and we go to project setup, we can see that Babashka uses bb.edn files to manage a project. So I'm going to create one here, new file, bb.edn. And if we look at the example setup, it's super simple, very much like a deps.edn file. Oops. Let's copy it here. And for the path, I'm going to change scripts to source. And for dependencies, I don't have any dependencies yet. So I'm going to save this and let's create a new folder here called source. And inside of that folder, I'm going to create another directory called passman. And inside this passman directory, I'm going to create an app.clj file. And then I'm going to namespace it as passman.app. Save this. So now I want to create a main function. And I think if we go back to book.babashka, we can copy one here. So let's just copy this main function. I'm actually going to get rid of that underscore. And we didn't really need to copy this. So let's just print line, hello world, let's do that. And now we should be able to execute this with Babashka. So I'm going to open up my terminal. Let's copy this line to execute this. And our namespace is passman.app. And here it'll look for the main function. Cool, and it's working, hello world. The next step is let's pass some CLI arguments to this. So if we go to the top here, we can see that Babashka actually comes with Clojure tools.cli for passing command line arguments. Cool, so let's go to that. And what I'm going to do here is look at the quick start guide. I'm going to copy this require. I see it has this pass ops function that we're going to use. Save that. And let's copy the example command line options. I'm going to paste that here. I'm just going to minimize this on the side. And let's copy their main function. So I'm going to copy this and paste it here. And now if we execute this, cool, we can see we have options kind of working, but we're not using anything. So let's actually just think about how we want this password manager to work a little bit. So the first thing I want to call passman, and I want to be able to pass through a website. So let's say facebook.com and a username for it. So like test user. And if I execute this, I want my password to be copied to my clipboard. If I pass through like G, I want a password to be generated for this user and this website. And if I go passman list, I want to see a list of all the passwords I have stored in passman, but a list of the usernames and URLs, not the passwords. Let's start off by making this passman list work. So I'm going to close this here. We don't need this. We don't need this one. Let's just use the list. So I don't want a single argument for it. So I'm going to pass through null. And here I want to pass through list. So now if we evaluate passman app with the list argument, you'll see that the list option is true. So in this case, I want to list all the domains and the usernames for the domains. Let's go here and let's create a let binding. And I want to get my options out of these past options. So let's do this. Let's get past options. And then to get the options, we can just get the options out of these past options. So if we just return those options, we can see we have, okay. And that's because, so okay, so options is not actually in our let binding. Let's put it in. And now if we execute this, cool, we can see that list is true. So now to do something when list is true, we can use cond. So I'm going to use the cond function. And basically what cond does is it allows us to pass through a condition here. And in this case, the condition is, you know, if there is list in options, then evaluate something here. So here, let's just run print line list password, well, list stored passwords or something, I don't know. So now if we evaluate this, list stored passwords executes. Cool, okay. So I think right now we can actually start up a REPL to help us. So I'm going to start a project REPL, and here I'm going to use Babashka. I'm using Clojure, and I can just exit there and close this. Now we should be able to evaluate this file, load current file and dependencies, and now we should have a REPL running, +1 Cool, and it's working. Let's move that to the side. And let's work on listing these passwords. So the way I want it to work is when we store a password, we're going to keep the entry in Sqlite, but we won't actually store our password in Sqlite, and I'll get to why just now. Let's create a database namespace. So I'm going to create a new file, db.clj, and here we're going to work with our database. So I'm going to namespace it to passman.db, save this, and for our database, like I said, I'm going to use SQLite. And to deal with Babashka, what we need to do is actually use a pod. So let's go back to the Babashka book and look at pods. So pods are programs that can be used as a Clojure library by Babashka. Let's go check out the pods in the pod registry. And if we go down here, let's look for SQLite. So interact with SQLite 3. That's exactly what we want to do. So I'm going to click on this. So to use this pod, all we have to do is go require it. So let's require the ability to use pods. So here we can now evaluate this, and now we have pods available. So we can go pods, load pod, and the pod we want to load is this go SQLite 3 pod. And if we evaluate this, it'll download the pod. And now we can require SQLite 3. So if we evaluate this, now we have SQLite. First thing I actually want to do is create a DB name. So I'm going to define DB name, and I'm just going to call it passman.db. Evaluate this, and let's look at how we can create our database. So we can just use this SQLite execute function, and here what they're doing is they're creating these queries themselves. So if we go here, we want to execute on, well, let's just put this in a comment. They're basically typing the query out themselves, but there's a cool library in Clojure that allows you to create queries really easily, and that's Honeysql. I'm going to actually just get rid of this and replace this temp foo DB with our DB name. And now I want to include Honeysql into our project. So I'm going to go back to, I'm actually going to go back to Google, and I'm just going to search Honeysql. And to include it, we just copy this. We just copy this deps.edn include. So let's go here, and we'll go back to our bb.edn, save this here, and now we'll have Honeysql in our project. So we go back to our DB, and let's require Honeysql here. Well, actually, I don't know exactly what to require. Yeah, I'm just going to require Honeysql as SQL. Save this, and let's evaluate this namespace again. Okay, I think we're going to have to restart Babashka. So I'm going to go start our project REPL again, click on Babashka, exit this. Cool, and now I think we can go back to our DB namespace. There's this, load current file and dependencies. Yeah, and now we'll have Honeysql, and let's use it. So we want to execute, basically creating a table. So to do that with Honeysql, we can go SQL/create. Okay, this is not what I was thinking about. We need to actually also include something else. So if we go back here, oh, okay, helpers. So I'm just going to copy helpers. And I require this as H. Evaluate this. And now we can use H create table. And the table I want to create is passwords. And well, let's actually just see how Honeysql works. So I'm just going to evaluate this here. Cool, you see it creates a map, and then we can actually thread these maps through to each other. So we'll create a table called password, and then I want to add a column. So we go with columns, and then we pass through a vector, and then more vectors. So we'll have a URL, and that will be text. So now if we evaluate this, we'll see we have our map is extended with columns, URL, text. And then at the end of this, we can actually evaluate SQL format. I think it's format. Evaluate this, and yeah, and now we see that we have some SQL syntax, and we wrote it with like some pretty nice Clojure code. So we'll want a URL, and we'll want a username, and that will also be text. We'll want the URL and the username to be unique. And to do that, we'll create another vector, and inside of that, we'll create another vector. And then we want unique. We don't want to name this function, so we'll say null, and we'll pass through URL, and we'll pass through username here. And if we evaluate this, we'll see that we'll have a unique URL and username. Cool, and that's what we want to create. So I'm just going to copy this, and sorry, everything's a bit too big here for me.
That's what she said.
Get rid of this, and now we should be able to create our database. So I'm going to evaluate this, and we should see passman.db is created. Cool. So let's create a function here called define create database. It doesn't take any arguments. We'll copy this and we'll paste it in here. There's one thing I want to do. I want to check if the passman.db exists. I don't want to execute anything. So let's check for that. And Babashka has a way that we can use the file system. So if we go back to book.babashka and let's check libraries, I think there's a file system. Yeah, Babashka file system. So I'm just going to click here. To require it, we just copy this and we paste it in here and evaluate this. And now we have access to the file system. I think it has like a file exists thing. So fs file exists or exists. Yeah, exists, and I think we can pass through DB name here. If we check this, okay, it exists. If we delete it and we evaluate it, it doesn't exist. So what we can do here is we can say when not fs exists DB name, then we can execute this. Now we can evaluate this, and now if we execute create DB and we evaluate it, cool, we have our database here, and if we evaluate it again, nothing will happen. Cool, okay, so now we've created our database. I want to create a way to insert a record into the database. So let's create a function here. Well, actually, let's create it below create DB. And I'm going to call this insert password. And it's going to take a URL and a username. So what we want to do here is we want to write Sqlite execute, and we want to execute it on our DB. And let's look at creating syntax to insert a record. So if we go back to Honeysql, let's see if we can see an insert query here. Yeah, okay, cool. So I'm actually just going to copy this and let's paste it here. And we want h insert into, and we'll insert into passwords, or into passwords. I'm going to call this passwords and delete this. So insert into passwords, columns, and that would be URL and username. And the values would be, let's say, facebook.com, and username would be dan@test.com. If we evaluate this, we should see, okay, we can't find these because they're not in the right namespace. Okay, now let's check this out. Insert into passwords, URL, username, and our values. Looks good. So what we can do now is we can actually just grab this and paste it in here. And instead of facebook.com, we'll pass through our URL. And instead of this, we'll pass through our username. So now let's just recreate our database and let's try execute insert password. So we can go insert password. We haven't evaluated it, so let's just evaluate it, and then we can run insert password and say facebook.com and dan@test.com. So if we evaluate this, no such table, passwords. Why? Okay, because we have to evaluate the create DB function, then we can delete our database, then let's recreate our database, and let's insert password. Cool, so now we can see that we've inserted a password. Let's look at how we can grab that out of our database. Okay, so now I actually want to list the passwords that we have stored in this database. So I'm going to create a new function here, and I'm going to call it list passwords. So define list passwords. And here we're going to use Sqlite again. And here we see there's a query function, so I'm going to use that because we're not executing anything. And we're going to query on DB name. And let's just go to this comment box, this comment form, and see if we can create some query syntax to get our passwords out. So let's go H. We want to select, and we want to select our URL and our username. Let's go H again, and we want to select from our passwords database, well, our passwords table, and let's go SQL format, select URL, username from password. So that's pretty cool. Looks exactly like what we need. So I'm just going to copy this here and paste it here. Evaluate this function and actually just rename it so it makes sense, and then evaluate it. And let's try run it here. So we'll run list passwords. Cool, and we can see that our password did actually store in this database. So now what I want is, if we go back to our app and we have list options, I want to see those passwords. So the first thing I want to do here is get rid of this. Here we can go, let's include our database namespace here. So let's require from passman.db. Let's use refer, and let's refer to the list passwords function. And let's just run list passwords here. Save this. And if we go back here, let's clear out our terminal. Oh, that was our repo. Let's clear out our terminal. Well, let's clear out our terminal and we can run list. Cool, and we see that we are listing our passwords, but this is kind of a crappy way to list them. There's a much nicer way, and that's by using a library called table. So let's go to Google and let's Google table Clojure, CLI. And it's table. So let's include the table library. Go back here, go to bb.edn, and we'll copy it here. Then what we can do is let's just restart our repo. And let's just check out this GitHub repo. Cool, so here's the repo. So links to all these repos will be in the description, but I'm actually going to add them to the project as well. So let's add table, and we used Honeysql. And we're using this tools.cli. And now we can just get the documentation really quickly when we need to. So let's go to table, and we'll see that it's super simple. We just run the table function and it will automatically create headings using the keys, and the values will just be displayed as the rows. So let's see what happens if we evaluate. Let's make a comment here, and let's just load current file and dependencies, and let's run let's include table. So let's go back here and require table as t. Evaluate this, and now we should be able to run t table and list passwords and check what it does. So URL and username are automatically the headings, and we have a list of our the URLs and usernames for our passwords. So that's pretty cool. So I'm just going to put this here so that when we list our options, we'll evaluate that And that's cool. So now we have a way to create Sqlite database, and we have a way to insert a username and a URL, but we don't have a way to store our passwords just yet. So let's look at doing that. So the first thing I actually want to do is create a way of creating passwords. So I've already made a video on a password generator using Clojure as the command line tool. And I've got that in a GitHub repo, so I'm just going to go there. So downloads the space, CLI password. Hopefully I'll get it. Yeah, so here's the video. Go here. Here's the GitHub repo. And I'm just going to grab the password generator. It's in password. Cool, and it's a super simple way to generate a password. So I'm going to copy this. And I'm going to create a new file here. I'm going to call it password.clj. I'm going to give it the namespace of passman.password. And let's just copy and paste the code in. And I'm just going to also copy and paste this file at the top here to see where I got it from. And if we evaluate this namespace, or I don't know if our REPL's still running. Let's just restart our REPL. And let's load this current file in dependencies. And now we should be able to comment. And if we go generate password and provide it a length, let's provide it a length of 50, we get a password of 50 characters long. Cool, so we'll use this to generate our password. So if we go back to app.clj, so now we need to accept that G argument for generate, and we need to accept an argument for length. So I'm just going to go back to CLI options because I want to provide a default value for the length, and I think the default value should be 40. So let's just copy this and we'll say L, and this will be the length, and we'll say this is length and password length. And we'll default it to 40. And we can keep this actually. This pass fn, this checks that this is an integer, checks that the value we pass is an integer. And if the validation fails, must be a number between 0 and 65,536. That's fine. I'll keep that. Something is not happy here, and it's because I need square brace here. Can evaluate this. So now also, if we just print our options out here, evaluate, not resolve symbol, pass ops. Okay, so we need to just evaluate this, evaluate this. So now what we can do is we can run -main with no arguments. And we can see that we'll have in our options a map, and there's a key of length and a default value of 40. So now if we went to our command line, and let's just go to ZSH, and we pass through L with a value of 60, we can see that we have a length of 60 here. So we can just change the length of our password. And if we don't pass this through, it defaults to 40. Cool. So now I also want to pass through that G flag so that we know if we need to generate the password. So let's create another vector here, and we'll say G, and the long version of this will be generate, and this will be generate new password. Evaluate this, and now if we go back to our terminal and we pass through G, we can see that generate is true. So if generate is true, we want to generate a new password. So all we need to do here is if we check for generate on our options, go let, and we'll create a new password here. And this password will be from our password namespace. So let's include that here. We'll get passman.password, and we'll refer to the generate password function. Evaluate this. And now we'll generate a password here, and we'll pass through the length from our options. So we can go length options. And if we just return this here, we'll see a password. So let's go back to terminal and we'll say generate, and we'll see it returns us a password. We're still printing our options out. So first, when we generate a password, we need a URL and a username. So let's add those. So I don't want to add those using these. I just want them to be regular arguments. So if we just print out the options, the past options here, and execute, I want it to look like this. So I want it to look like facebook.com and let's say test@com. You'll see that those come through as arguments. So the first argument must be the URL and the second one must be the username. Those are in an arguments key in our past options map. So to do that, so to get them out, all we need to do is, so we can get our URL, and that will be the first item in our arguments from past options, and we can get the username, and that will be the second item in our arguments. So basically what that does, if we had a list here of 1 and 2, second would get the second one and first would get the first element. Easy enough. So now that we have a URL, a username, and we know that we want to generate a password, we need some place to store this password securely. So let's go back to the book.babashka website. Let's go to pods and go to the pod registry. I'm going to look at this stash. So this is encrypted text storage, which is basically exactly what we want. I'm just going to take a quick break now, go for a walk and come back and finish this tutorial up. So I just finished recording this video yesterday and I realized my screen wasn't recording. So I backtracked the project a bit and I'm hoping it's exactly where we left off. So if something's weird, it's because I didn't backtrack enough. So we want to add encrypted text storage. And I want to use this roro kimdom stash. And the reason why we need encrypted text storage is because even though we're storing data in Sqlite, we've created this passman.db file, we can actually still see the contents of that file. And we can do that by running hex dump with capital C as an argument, and then we pass through the name of our database. And here we can see what we're storing inside of the database. And obviously we don't want that with our passwords. So the way we get around that is by using encrypted text storage. Well, I chose to use encrypted text storage. So let's look at how we can add this. I'm just going to open this in a new tab. And if we go to the scripting examples, and then we click on Babashka, and then we can check the stash.clj. Cool, we can see that we've actually got some code already written for us, which is great. So I'm going to grab some of these functions. So first off, I'm going to go back to our project, create a new file here, and I'm going to call it stash.clj. And I'm going to namespace this as passman.stash. And here we're going to want not the path of the stash command, but we want the file, the stash file path. So I'm going to copy this and I'm going to call it passman.stash, and we can evaluate that. Let's evaluate this namespace also. And here we want to load the pod. So let's copy this. And instead of loading it via the stash command, let's go and load it. We want to load this. So we can copy this here. And we don't need a vector. And we should just be able to put the stash command there and the version, which is 0.2.0. And I think that'll work. Yeah, cool. So now we've loaded it in. So now let's go back to the script and we want to actually require the stash command. So I'm going to get this out of here, and just underneath here, we can go, well, we want to require, and if we evaluate this, okay, I think we need to pass this through as a symbol. Evaluate this, and cool, now we have stash. So we can run all the stash functions. Great. Okay, here. So here's the stash init function. So this will initialize a stash file for us. So I'm going to grab this out of here. Here we can see it's getting the stash encryption key from our environment variable. So we're not going to do that. So I'm going to not have that in the comment. And here we want to pass through our password. And instead of e key, let's just grab this out of here and we'll use password instead of our environment key. And if we evaluate this, now we should be able to initialize a stash. So I'm going to write a comment, and I'm not going to call this function stash init. It's in the stash namespace. I'm just going to call it init. So now we can run init. Well, actually, no. Let's call it stash init. Makes more sense. Then let's run stash init. And I'm just going to give it the password of password. And if we run this, we see that we have a stash file created. Awesome. So now let's actually add stuff into the stash file. So if we go down here a bit, stash add. Cool. So adds a new node under a parent. Yeah, adds a new node under a parent. So we should be able to add something to the stash. So let's evaluate this here. And then we go stash add, and we want to add a password. The way I see us wanting to add a password is by having our URL, which is facebook.com, our username, which is test. Let's see what we used as a username here. dan@test.com. So I'm just going to use the same one here. And then a password, which let's say secret. I'm going to actually not use the stash add function. I'm going to wrap this. I'm going to call it insert password. And let's create a function here called, or maybe add password. And it'll take our URL, our username, and our password. And we'll call stash add. And we see stash add takes a parent ID. So for now, I'm going to just add all the passwords to the same parent. So the parent ID will be 0. And a key and a value. So the key, what I want to do for the key, because we know it's going to be unique, is combine the URL and the username. So we can go string URL and username. And that will create a unique key from our URL and username. And then the value will be our password. So we can evaluate this. And now if we run this, we get 1 because we've just added a new node under our parent. So now we need a way to retrieve this. So let's go back here. And I think there's a way to get all nodes. Stash nodes, no. Yeah, stash nodes. Get all nodes stored in a stash. Perfect. So I'm just going to grab this function out of here, paste it here, evaluate this. And now if we go stash nodes, cool, we can see that here we go. Here's our key, which is our URL combined with our username and the value. And if we provided a parent ID, then it'll look for nodes in that parent ID. So like if we provided 1 here, we'd get nothing back because we're not using that parent ID. Now we have a way to store our password secretly, and just to show you that, so if we run hex-dump c on passman.stash, everything is encrypted. We wouldn't be able to find our value in there. So let's go back to our app.clj file and start using this. So here we generate a password. That's cool. What we actually want to do is before we generate our password, when we generate a new password, we want to initialize our stash. So we can go do, and okay, so now we need the stash namespace. So I'm just going to include that at the top here. So passman.stash as stash, and let's evaluate this. Now we can initialize our stash. So stash, stash init, and we need a password. So now we need the user to enter a secret password that will initialize their stash. So if their stash has been created, it will just be able to access it. So I want like a function here called, I don't know, password input or something, password input, and that would get the input from the user. To do that, all we have to do is create a new function here, and we can call it password input. And what we want is we want to like print line, enter your master pass, enter your master key or something like that. So we can use some Java interrupt here to interact with the console and read a password. So we can get from system console. So on here, there is a function called read password. So .read password. And then we want to convert this to a string. So we just instantiate a new string. And I think that's it. We can test this by making it the first thing we input. So let's print line password input here and see if it works. And now we can use Babashka to run this. So what's it? bb-m. Yeah, bb-m. And let's run, well, list should still work. So list, now we enter our master key, test. Cool. So I inputted test and we get test. Great. So that works. So now we've initialized our stash. We want to store inside our database the URL and the username we entered. So I'm going to actually, instead of using the referrer for this list passwords function, I'm going to get rid of that. I'm just going to say, use our DB as DB. Evaluate this again. Here, list passwords will be DB list passwords. And here what we'll do is, we'll go DB insert password, and it takes our URL and our username. And then we can go and add this password to our stash. So we can stash, add password, URL, username, password. Then we can print line, added, asked password, added password. Yeah, okay, so let's see if that works. I'm going to save this and let's try and generate a password. Open up our terminal. G. So here we want to add a password with the URL Facebook, the username test4@com, and we want to generate it. So let's also just output our password here. Password. And let's see what happens. Generate. Enter your master key, and our master key is password. Cool, so it added password, and here's the password that it added. So I don't want it to actually ever display the password in the console. I'd rather just copied it to our clipboard and then we can paste it. So instead of displaying the password here, I want to create a function that will copy it. So let's copy it. Let's create that function. So I'm going to create a new namespace here called clipboard.clj and namespace passman.clipboard. Evaluate this. Okay, so I'm going to create a function here called copy, and I'm going to use terminal command. So if you're on a Mac, this will actually only run on Mac. But if you're on a Mac and you go echo some text and you pipe that through to pb copy, it's going to copy that to the text to the clipboard. So Linux has its own command, and I have no idea how you would do that on Windows. We're basically going to run this inside of Babashka. We're going to write a function called copy, which takes some text, and we're going to require the sh function from Babashka. So if we go back to book.babashka and we check the process namespace, yeah, let's search for this on Google. And we want to use the sh function. First, let's require it. So I'm just going to grab this line here. And we'll require the Babashka process, and we'll just want to refer to this sh command. So let's just find sh being used. Okay, cool. This, I think we can use this. Let's grab this here and paste it in here. Here we can go echo. We want to run echo, and we want to echo out our text. Then we want to pipe that through to sh again, and we're going to run pb copy, and then nothing in the out. So let's make a comment block and run copy hello. Evaluate this. Could not resolve symbol sh. Okay, so evaluate this, then evaluate this, and now if we run this, cool, we get nothing back. Okay, but we can paste our text. Cool. So let's go back to our app and include the clipboard. Well, let's actually just use the copy function. So we'll just import that one. Now, password added, and then we can copy password. So now if we run this again, let's go up, test 5, enter your master key, so password. Cool, and we can paste our password. Awesome. So I'm just going to also stop printing these past options out all the time. Now let's create a command to actually retrieve the password. So basically what we want is, if we ran this without the G, we want to retrieve the password. Right now it does nothing. So we can create a new condition here, and we can say, so if the first one goes through, then we just assume there's a URL and a username. But now we just want to check if there is a URL and a username. Then we want to execute something here. So do, and what we want to do, we want to get our password from the stash. So let's go back to our stash and add a way to do that. We have a function to get all of our nodes, but we have no way to actually look up a key. So let's define a function here called get password, or find password, because that's what we're doing. And we want a URL and a username. And we can create a left binding here, and we'll say our nodes are our stash nodes. And the lookup key is going to be string of the URL combined with the username. And then what we want to do is we can say the found node. We can run filter on our nodes. Well, let's call this nodes. And here we can get function that will take in our node. And what we want to do is we want to check to see if the value, not the value, if the key, so the node will have a key here. So if the key of the node is equal to our key, then we found a node, and then we'd want to get the value from that node. So we want to retrieve the value from that node. So value off of the found node. So right now, this is actually going to return us a list of nodes. So we can actually just get the first found one. And if we evaluate this, that should work. Let's go down here, and we want to find password. Cool, and it found our password. Let's save that, and let's go back to our app. And what we want to do here is we want to init our stash with the password input. And then we can run stash find password with our URL and our username. And then we want to copy it. So let's put that in a let binding. So we'll say we'll let our password be our found password, and then we can just copy our password. So if you're writing the script to distribute, I would add some error checking, but I don't think it's necessary right now. And then we can print line here, password copied to clipboard. And actually this should be the worded the same here. Password copied to clipboard. Cool. So now if we run this, okay, I misspelled username here. Let's rerun this into your password. Cool, and I can paste the password. Great. I actually want to run, go back to the go back to the DB. I always want to run this create DB function when this file evaluates, because there should always be this DB. So here, I'm going to delete this database here, and whenever we run this namespace, I want create DB to run. And it'll check for us if the database is there. And if it's not there, it'll create it. So now let's go back and let's try add a password. Okay, the key already exists in our stash. So I'm just going to delete both the DB and the stash. And now let's try this again. Password copy to clipboard. Cool. So I also just want to check that the length and everything is working now. So I'm going to delete our database. I'm going to delete the stash. What I'm going to do is I'm going to run bb_passman.app test11, and I want to create a password of length 2. So I'm going to create a new master key called pass. And if we paste this, cool, that's 2 characters. If I make this 20, pass. Cool, it's a duplicate insert, so that's not going to work. So let's create a new username, pass. Cool, and that works. Awesome. If we just run this again and run this with list. Cool, we list our passwords. I think that's it. So now what I want to do is compile this into a script so I can execute it without having to run bb and then point to the main method of passman.app. I just want to run like passman like that. So to do that, we need to create an uberscript. So I'm going to create a new file here. I'm going to call it create uberscript.sh. So I've already created this, and I'm just going to paste it in here. So let's run this. So create uberscript. Cool. We can't run it, so we need to change it to an executable by running chmod +x on create uberscript. And now we should be able to run this again. So now if we go check our out directory, it's compiled all of our namespaces and everything into one script that will run for us. So now what we can do is we can go run out, passman, and okay, we don't have any function that's default, so we can go list, and it'll list our passwords. And if we go, let's generate a password. So let's say twitter.com, dan@twitter.com, and we want to generate a password of length 100. And let's create a, well, it's going to be using our same master key from the last one, but that's fine. Pass. And it generated a password of length 100. And then if we run list again, we'll see that our password was added there. Cool, and that's how we can make a password manager using Babashka and Sqlite and the stash file. I hope you guys enjoyed this one. Please like the video if you did, and let me know what other videos you want in the comments below. Catch you in the next one. Bye.